1.25 times 10 to the power of, so that would be 1, 2, 3, 4, 5. 5 to the power of 5.
That's it. It's okay. How do we do this?
Okay, so it's like doing algebra, isn't it? So you do the numbers first. So 9 times 2 is 18 times 10. And then with the powers, you add the powers. So it would be 10 to the power of 6.
Yep. And convert your answer into standard form.
Okay, so in standard form it would be 18. Oh yeah, so because it's 18, isn't it? So basically, we want to make it 1.8, and what happens there is we're dividing, so the powers go up, so it would be to the power of 7 times 10 to the power of 7.
Yeah. Let me see that one. Okay. So sometimes they have brackets around them, but you can just ignore the brackets because everything has been multiplied.
Right. Yeah, I had some trouble with some of the end exam questions on a paper that I practiced.
So we'll get there in a sec.
We can probably get to that a bit later, maybe.
Well, I mean, we're nearly there now. How would you do this?
Okay, so this is dividing. So so we want to 4.2 divided by 7. So essentially, it's 42. So it's 6. 7 times 6 is 42. So there's a decimal place there. So that would be 6.
I would change the top into 42.
Right. Okay. Right. Okay, so in that case, it'll be 6.
So what would be... So 4.2 times 10 to the 8 is equal to 42 times 10 to the what?
So... Oh yeah, so it's going to be... so we're multiplying, so the power's going to drop.
Mm-hmm.
So it'll be to the power of 7.
That's it.
So now... do the actual division. So it'll be 42 divided by 7 is 6. So 6 times 10. We're multiplying the powers. So 7 take away 4 is 3 to the power of 3.
Yeah. So if it's a decimal, make it not a decimal.
Right.
Let me see. Calculator. Okay, let's try the top one.
Okay. So again, it's if we make 3.5 into 35, it'll be the powers will go up. No, the powers go down. So it'd be 35 times 10 to the power of 7. Should I say that? Yeah.
No.
Actually, no. Sorry, it's 5.
Yeah.
Yeah, my bad. And What we divide, it's going to be, so we put the 5 times 10 to the power of minus 3 underneath, and that'll give us 7 times 10 to the power of, so it's minus 3, so 5 take away minus 3, so we're going up, so it's going to be 8.
Yeah. Well, there's a calculator. Just put them in your calculator. Not obvious. Okay, let's try this one.
Okay.
So I believe it's non-calculator.
Right. Okay.
Actually, I didn't. Okay, what is this?
Okay, right. This is standard form. So it's going to be 3.7. Times 10. It's going to be a minus, so it's going to be 3, 4, minus 4.
Yep. So maybe you are okay. Okay, and then working in reverse.
Okay. So it'll be 0. So it'd be 0.04 times and then 3.
Yeah. So 5 zeros, 3. Don't forget the decimal.
Yeah.
And then this is just miscellaneous, and that's miscellaneous. So this one.
Right. Okay. So let's stand for, so 0.06. So maybe 6 times 10 to the power of minus 2. Times 3 times 10 to the power of minus 4. I'll give you an answer this time. So the one at the bottom is just going to be 1 times 10 to the power of minus 2. So this is actually what I got wrong in the exam, like in the practice paper. So would you just do the multiplication first at the top?
Yep.
So 6 times 3, it's 18. So it'd be 18 times 10 to the power of, so we've got the minus 2 plus minus 4. So we're going up, so up 2 and then up another 2. So
that would be plus 4. This is plus minus 4, so you're adding a negative.
Alright. Adding a negative. Oh yeah, sorry. So we're going down. So it will be minus 4. It'll be minus 6. 10 to the power of minus 6.
Mm-hmm.
So that's what's on top. Divided by 1 times 10. Divided by 1 times 10 to the power of minus 2. So that goes underneath. So this is confusing me so much.
How many ones are in 18?
18.
And so it's 18 divided by 1 is just 18.
18, right. Okay. So 18 times, and then times 10 to the power of, so minus 2, minus 6, take away minus 2, so that's plus, so that's minus 8.
That would be minus 6 minus 2. This is minus 6 minus minus 2. So
Alright, so we're going up. Minus 4.
yeah.
Right, so I've got to give it in standard form. So it'd be 1.8 times 10 to the power of minus 5.
Times 10 to the, let's see, this one got smaller.
Right.
And so to keep things equal.
So it got smaller. So that means we've added a power.
Yep.
So adding a power to minus 4 is actually minus 3.
Yeah. It becomes less negative.
Yeah.
Any questions there?
No, it makes sense. It makes sense. It's just pretty tricky with the minuses.
The only tricky bit is the minuses.
Yeah.
Minuses and fractions will never be easy. No one will ever find them easy. Okay, yeah. 1.8 times 10 to the minus.
Right, write these in order of size. Start with the smallest number. So I guess the trick here would be to write it all as ordinary numbers.
Yep.
Yes. So 25. That's 1, 2. So the first one is 250. Well, as in not the smallest number, but it's technically 250. The other one, so 0. 2, 5, so 1, 2. So the next one is 0.025.
Mm-hmm.
So now the smallest one is obviously going to be 0.0025. That's the smallest. And the next smallest would be 0.025. And then 250.
Hold on. They want it in the form that they gave it to you.
Oh, right. Write these numbers in order. So I'll start this. So they want it in So if that's the smallest, the next smallest. So the next one would be 2.5 times 10 to the power of minus 2.
Yeah.
And then 2.5 times 10 to the power of 2.
Mm-hmm.
And then 2,500.
Yeah. Okay, let's try this one.
Okay, give me
So you don't have to because it's everything times everything.
okay.
Because if there's no different thing like plus or minus or anything.
Right.
But I would put it all in.
Right. Okay, the answer I have is 7.452 times 10 to the power of minus 4. So it's minus 0. Seven, so I have 0.3 zeros, so four zeros with a point after the first one,
Mm-hmm.
and then 745.
Yep. Slightly different, and it wants the answer in standard form.
Okay. All right. Subtracting. Okay, so what we're doing here is if you do it as 25, take away 5, which is 20, but with the decimal point it'll just be 2. So 2 times 10 to the power of we want to make the powers the same, so
And just put in the calculator.
it's just calculated. Oh, okay.
Yeah, the rest are calculated.
All right, so 2.6 times 10 to the power of 7. Take away 5 times 10 to the power of 6. So the answer is divided by 2 times 10. So the answer is 7,500, but in standard form, it's 7.5 times 10. 7.5 times 10 to the power of 3.
I have lots more zeros than that.
Oh, really?
I would have something like 7.5 times 10 to the power of 1, 2, 3, 4, 5, 6, 8, 9. Did you remember to do a minus 3 on the bottom?
I did, yeah. Let me do it again. 2.6 times 10 to the power of 7. Brackets in it.
See, now it's a mix of times and minus.
Right.
So, yeah, like I said, don't think about it. Always just copy paste it in.
Right, okay. So, bracket. Let's bracket. Divide by 2.8 times 10. Minus 3. So the answer I have is 4.642857,143 times 10 to the power of 10.
No,
I've done something wrong there, haven't I?
it should be still 7.5.
Do you have to put brackets even with the division? Like when you like 2.8 times 10 to the power.
Let me screenshot this thing. Cause it's weird. Do I do beautiful? Does it? So this is my calculator.
Right.
So it's cut out the.
Right. So 2.6 times 10 to the power of 7. Close bracket. Take away bracket. 5 times 10 to the power of 6. Close bracket. Divide 2.8 times 10.
Are you pressing divide, or do you have the whole thing as a fraction?
Oh, I'm pressing divide.
Yeah, that's only dividing the last two then.
Oh, right. So you have to do it as a fraction.
Yeah, just literally copy paste, like exactly the question. Just put that in.
Okay.
And you'd start with the fraction.
Right. Uh, 2.8 minus 4. Yeah, so it's 7500000. Yeah, I'll do it as I'll write it the answer in standard form now. So 7.5 times 10. It's a power of 9.
Yep.
Sorry about that.
Alright. Yeah, so all these quiffed. So this is calculator. I think you're okay for both of these actually. I think you're okay.
Yeah, that's fine.
And just because it's on a calculator paper doesn't mean you have to use your calculator. Like, I'm sure, hang on, let's check. 4.7 times 10 to the minus 1. Press equals, press SD, yeah, 0.47. So sometimes.
Right, okay.
Let's see, so this one. So that looks like they're less complicated. This is a less complicated one. So that would just go in the calculator.
Right.
And that time they didn't have any brackets.
Sure. Should I give this a go?
Okay, how about this?
This is the question that I had trouble with.
Alright, try it now.
Right. So this is a calculator question, right? Okay. So x is basically, so it's basically going to be 8.5 times 10 to the power of 9. Take away 4 times 10. 10 to the power of 8. Oh shit. There's a fraction. So I don't know. Take y, which is 4 times 10 to the power of 8. X, so 8.5 times 10 to the power times 4 times 10 to the power of 8 equals. Okay, so the answer, like once I put everything in the calculator, the answer I get is 2.38 2.3823529141 times 10 to the power of minus 9. And what I would do with that answer, I would then square it.
So that is equal to p squared?
Oh yeah. So in order to find out what the value of p is, would you just square it? You square that answer.
P is already squared.
Oh.
You want to get rid of the squared?
Oh yeah, to get rid of it. So you not square it. I'm saying the wrong word. The symbol with the kind of
square root.
Square root. That's it.
Yeah.
That's what I meant. So if I hit answer, oh shit. What have I done? So square root answer. So when I square root the answer, I get 4.880935,301 times 10 to the power of minus 5. So it's asking for two significant figures. So it would be 4.9. No. Two significant figures.
4.9 is correct?
Yeah. Okay. 4.9 times 10 to the power of minus 5.
Yep. because it's just like 5 zeros and then 4 9. And so it's got two numbers with significance. Yeah. Any questions there?
Makes a lot more sense now, doing it with a calculator.
Okay, so yeah, it's calculator question. Copy and paste it in and square root it. Start with the fraction first and go from there.
Yeah. The only thing is, just the two significant figures. When it's 4.88, it just catches me out. So the significant figures are usually, I thought they were the two numbers after the decimal point, but in this case, zeros.
So if we were to write it the long way, it would be 1, 2, 3, 4, 5, 4, 8, 8, and all the other stuff. Two significant figures is the first two digits that are not zero.
Right.
So all these numbers have no significance because it's like if it was money, it'd be like £0. You know, it doesn't have any. Yeah, it doesn't have any value. Only a zero only counts if it was like in the middle, like 408.
Yeah.
Something like that.
Yeah, I forgot that it's because it's a minus, like a negative number.
Yeah. Two different ones. Oh, did I delete it? Oh, hang on. So, and so I wanted to do one of these.
Right, okay. So everything is different, so three times the top one by 4. So
and what would you times the bottom one by?
The bottom one be by 5.
And that would be to get the x's the same?
Yeah.
What would you do to get the y's the same?
To get the y's the same, times the top one by 3. Or the bottom one by 2.
And so which will we get the same, x's or y's?
So
we should do times 3 times 2. So both will work, but multiplying by 3 and 2 will keep the number smaller.
Oh, right. So make it easier.
Yeah.
Right. Okay. So, we'll go with 3 times by 3. The first one. Take times the first one by 3. 5x. So, 3 times 5, so it's 15x plus 6y. 3 times 11 equals 33. Now we write the 5. Actually, no, we write the do you now times? No, you don't do the bottom one by 2, do you?
Yeah.
You do. So it'd be 2 times 4, which is 8x. So 8x. So 2 times 4 is 6. So this will be 6y. So we want to minus 69. 2 times 18 is 2 times 18 16, 36. So yeah, 36.
And these are all calculated.
Oh, they're all calculated. Okay. So what we do now, we want to minus the 36.
What are we eliminating the x's or the y's?
Sorry, we're so we're going to eliminate the y's because they're both the same. So in order to eliminate, so we've got a plus and a minus. So plus 6 minus 6 give us 0. So we take away.
Different signs?
So 15 take away. So you just take away everything. So 15 take away 8.
Different signs?
Different signs. Subtract.
Same sign, subtract?
Same signs. Oh, add.
Yep.
Different signs, add. So we're adding. Okay. So 15 plus 8. So it's 23x.
Mm-hmm.
23x equals so 33 plus 56, 69.
Yeah. And these always appear on calculator papers.
Right, so 69 divided by 23 gives us 3. So x equals 3. And then we sub the 3 into the original one, the 5x. So we know that. So it's 15 plus 2y equals 11. Now we minus, we want to get rid of that 2y. So
we want to eventually get y equals.
Sorry, say again?
We eventually want to get y equals.
Oh yeah. So it'd just be 11 take away 15, subtract 11 from 15. So minus 11. So 11. Actually, no, we want to get rid of the 15, so
well
11 take away 15.
Yeah.
Which is minus 4. So 2y equals minus 4. So minus 4 divided by 2 is minus 2.
Well done.
Right.
So x is 3, y is minus 2.
Right.
And that's form archetype. So that's the one with the 2 different ones. So you could have times by 4 and times by 5, but it's easier to times by 3 and times by 2.
Right.
Just 'cause it's smaller. Different signs. So you add to eliminate.
Yeah.
And then just solve as normal. And in all these exam questions, the only other type is times 3 times 4. So same thing, you could do times 10 and times 7, but you can also do times 3, times 4, and so they're always one of those two.
Right. Okay.
So I think you're good. So that's everything for simultaneous equations, algebraically, and that's everything for standard form anyway. How was that for you, Pierre?
Yeah, it wasn't too bad. I feel a lot better about those tricky. I was actually trying to do them without a calculator. It must be crazy. But,
if it's on a calculator paper, no extra marks. Just write down what you've put it into the calculator. So if it isn't like given in the question, and that's your working out, and then you just write down the answer.
Great.
Anything in particular?
Okay. Well, that was fine. I'm gonna keep practicing the simultaneous equations. I get it, but I think with more practice, it should be okay. So we have a class on Friday.
Yeah.
Yeah, that's it. We're trying to think what we could do on Friday.